Welcome to my Java programming series where I'll go over the basics of programming and programming with Java. The first video is going to be very, very basic, and as we go through the series it's going to get more and more complex, but you don't need any background at all to start this first video. I'm just going to go over the very basic concepts and work our way up. First thing you're going to need is Java version 8 or higher. Java 8 introduces lambda expressions, which we'll be going over later on in future episodes, but that's not really important right now. It's just that you need to have Java 8 or higher, so you have that when we get there. The other thing you're going to need is Eclipse, and Eclipse is an IDE that is used to work with Java. It's a very, very powerful free program, and it's probably the most mainstream thing used in the industry. To download it, you go to eclipse.org/downloads. You should see something like this where it's called Eclipse Oxygen is the version, which I don't think I actually have Oxygen, but I have it on my other computer. It's the same thing basically. So once you download it and you have everything set up and you have it running, you should see something similar to this, except for without all these files here. To start a new program, what you want to do is you want to go to this left side panel here and right click, go to New, go to Java Project, and you can call this project name anything you want. So we're just going to call this Java Examples 1. We'll do Finish. Now you should see it appear over here on the left side panel. Go to it and bring down the drop down menu. Go to SRC and right click it. Go to New, go to Class, and you should see a window like this. If there's a package here, just delete that and leave it blank. We won't need that for right now. Go down here to public static void main string args and check mark that. For name, you can put whatever you desire. I'm just going to put session 1, I guess. And when you generate this, it's going to create a class. It's going to create the public static void main string args that we told it to. And it's also going to create this. This is what's known as a comment. And comments are used to basically declare in English what your code is doing. So if you have a bunch of code that's hundreds of lines long, in certain parts you can just put double slash and then put like something like this affects this var compared to this or whatever, this variable compared to this or whatever, and that's just for your ease. So when you come back, weeks or months later, you can sit down and say, instead of it looking all, translating it all through, your Java language, you can kind of sit down and say, oh, that's what I was thinking there. Because when you start developing complex algorithms and stuff, you can easily get lost in it if you don't view it every day. It also helps out other programmers because all programmers program differently. There are, if you're looking to solve something, there's generally going to be like dozens and dozens of ways you can actually solve it, and some are more efficient than others, and some are just different than others, and everybody programs differently. So for that sake, when you're looking at somebody else's code, if they have comments, it just makes your life a lot easier because you can actually translate in English, oh, this is what they're doing in this specific part of the code. So that's what comments are. First we're going to do is print text to the console. And this is the console down here. And this is just for your ease so you can actually see what's going on with the program if you're outprinting something. So to outprint stuff to the console, you do system.out then you do dot, and you can do either print or print ln. And what print ln means is print line. And what that basically does is, well, I'll show you. First we'll do print. And we will say hello. So it's system.out.print, parentheses, quotation marks, hello. And then we end the parentheses, and then at the end of all Java statements, you always put a semicolon. So always remember to put your semicolon. But if we run this by pressing this green button here, pressing OK, in our console we get hello. Now if we do this with print ln, or in most English terms you would say print line, we run it again, it does the same thing. However, if you look here, my cursor is here where we see it blinking, whereas with the other one, if we run it, our cursor is here. So it inserts a line break out of, so if you do print line, it inserts a line break out of whatever you're typing, which makes it really, really easy if you want something below this. So for instance, if I were to copy this and I were to change the bottom text to how are you, we were to run this again, it would look like that with a print line. Without the print line there on the hello, it would go like that. And that's basically how you would print to console. Now I have a little application I made in the top left corner here of something I made on my own. And this, if I can actually move this, I'll move it down here. This allows me to, create text really, really fast. And basically, if I do caps lock, it allows me to do these different things, so I can just print something like that. So if you ever see me and I just type it like super fast like that, that's what I'm doing. I'm actually using this. It allows me to do just commands really, really fast and efficiently. And I can actually hide this by doing Shift Delete. It's up there, but yeah, so if I do something like that, it's just using that. So declaring variables, there's different kinds of ways of declaring things. For instance, something can be an integer. To declare an integer, you would do int and then the variable name. So int, let's call it number 1, and we'll just do that. Another way is a double, which we will call number 2. This is how you declare different variables. The third, we could do something like long number 3, short number 4, and I'm going to go over what all these mean. Byte number 5, and then there's something, there's a float, but we're not going to get into floats because that doubles and floats kind of correlate together, and floats aren't really used as much unless you get into very specific things. Generally the standard's doubles, so we'll just go over doubles. But these are, kind of the main numeric data types that you can use. Now the int, this goes up to 2,147 something something something. So we'll just say this for now, even though it goes even, there's some other numbers there, but for the sake of simplicity, we'll say that. So ints go up to, just remember ints go up to 2.1 billion. So if you need to use something past that, you'd have to use something else. Doubles are decimals, basically. So something like this. Long numbers, if you're going past 2.1 billion, it's going to be a long. So 2.7 bill plus, you're going to use a long. A short, that goes up to like what, 32K, I think. So if you're using something between 0 and 32K or negative 32K, you're going to use it as short. And then byte is 127. So bytes, typically, they're just going to be in a couple dozen numbers, so those are it. Generally, you're just going to use int. I mean, there are some cases where that you're never going to be dealing with anything over 100, so you might want to use byte just to make it more clear. Or, you're going to use a double for decimals. Shorts and longs really aren't seen anywhere. But, I guess you could use a long if you're going over 2 billion. Those are the different kind of numeric data types. Then you get into the other data types, which are string data types, which are a character of letters, basically. So we could call string 1 hello, and we can also say the other kind of data type is a char value. So you could say char string 2 equals a, which is just a char is just a character value. It is only one letter, so it's either one letter with a capital A like this or lowercase. The other thing is you have to use this, I believe, for it. I don't think double quotations work, or do they? Maybe they changed that. No, they don't. And then the other thing are Boolean values, which we'll save that for another day because that kind of ties into something else. But basically Booleans are either like true, false, or on, off kind of Boolean logic, which you may already know already. So, but there's different ways of actually declaring these. And as you can see down here, I actually gave it a value. You can actually declare a string like this. It will let you do that. Or you can declare a char like this. So there's different ways of declaring them. So to initialize, you could either do something like this, where number 1 would equal 3. It would let you initialize that, and it would store the value 3 to it. Or you could just have it declared like that and store the value down here. String 1 equals hello, and stuff along those lines. So the next thing we're going to talk about is another way of declaring it is to finalize, or to final a value. And what final means would be final is a number that never changes. So for instance, let's say you have a game and you're creating a game, and oops, wrong thing. And let's say it's a scroller game. If you don't know what a scroller is, it's basically like Mario, where you go from here to here in this direction. let's say you have a set height of how far you can jump. And this set height never changes. There's nothing in the game to make you jump higher. There's nothing in the game that can make you set or jump lower. Now, you could actually initialize a value called, something like jump height, and have it, let's say it's set to 10. What final means is that this value never changes. And if you actually try to change it, like so, to let's say 3, it will give you this error of, remove final from here because you can't change final values. Which, if you did that, it would then let you. But what final allows you to do is it basically just sets aside and says, hey, this is a type of value that will never change within your program. Like, this is hard-coded, like there's no way you would ever change this. It's not used a lot, but it's something to be aware of. So next we're going to go over some math. So let's actually do, you can actually erase this. We'll set this to number 1. Let's call another integer here number 2, value of 30. Now to do math, it's really, really simple. We could say total value here. Yeah, let's do int total, value. We could say total value equals number 1 plus number 2. Then we could also say print this total value right here. So as you can see, declared our first number, which is number 10, declared our second number, which is 30, declared total value, but didn't give it anything because we're going to be doing that down here. And our total value is our number 1, which is 10, plus number 2. That is then stored into this. But to get this to here, we actually do this. And that's how we get that. Another thing is called concatenation. And what concatenation is basically the combination of, strings or numbers to get something totaled together. So example of concatenation is this. Your total value is, and then I'm going to put a space here because it has to have a space. I'm going to do that. So this is going to be a string right here. So your total value is space, and then we do plus this. And if we do this, you can see here your total value is, and it has our total value we have. To put a period in, we would do plus quotations for a string and put a period within those quotations. So then we would have something that looks like this. And this whole process is called concatenation. Another way of declaring variables is, a less common way is doing something like this, where you can initialize multiple variables at once. So you could do something like this, like int the x coordinates of a player, the y coordinates of a player, the z coordinates of a player. and that initializes 3 of these all at once instead of doing this. Does the exact same thing. I would say initializing like this is by each line is more common, but if you do have something like this where variables all kind of group up together, like coordinates of a player like this, or possibly int heights, width, or something like that, where variables kind of correlate together, you can kind of group them together like that, so you initialize them all together. Otherwise, I would kind of stray away from it because it is more common practice to do it by line, but just be aware that you can do it this way. Now we're going to ask the user for input. So to do that, I believe we do scanner input new scanner system in, I believe. And you'll see some squigglies on scanner here. You want to hover over that, then go down to import scanner Java util. What this does, this actually sets in input from something. Alright, so now we have to actually get that, so let's call this user input equals input dot next line, and next line actually gets it by string, I believe. So we can actually do next, and you can kind of scroll through these to get different ones. We should do next int, I believe. And it actually doesn't like that because this is actually a string here, because that's what I initialized it as. But we should do int here. We could copy this down here. Or actually, no, it's fine up there. Let me put this right here. We could actually say here, please enter a number. And let's comment this out real fast. And the way you do that is you just highlight this and then press Control/. It will comment that out, so this is no longer in our code, but it's still here. Ghosted in the background, I guess you could say. Then let's do user input. Alright, so let's run this, see what it does. So let's enter 15. Okay. So this is basically what it does. We say put it in a console, enter a number. It initializes the scanner. It takes that scanner and it puts that into an integer of user input. Then it spits out that user input to the console. That's basically what that did there. Well, we can take this a step further and have our user do math. Another good practice is always using what's known as camel caps. What camel caps is, it's just a way of writing like this for our variables. It's very common practice to do that for every word. Like maybe you do user input first, user input second, something like that, where each new word is capitalized. Some people actually do it like this, where the beginning of the word is capitalized. That is usually less common though. I typically always do it like this unless I'm, kind of zoning out and I just, capitalize the first word for whatever reason. But that is known as camel caps or camel case. Is it camel? It's camel case. Why did I say camel caps? Wait, is it known as camel caps? I know it's camel case. Do people say camel caps? I have no fucking clue. I think it's camel case. All right, so, oops, let me put this back up here. So camel case, just remember that's really good practice for code, and you don't want to make variable names like really, really long. Try to make them specific and 3 to 4 words as the maximum. So let's do some math where we tell the user to, we're going to do some math here. And we're going to paste this up here. We're going to change this to, this is a math program that adds numbers together. And that's going to say that on one line. And then that's going to say that on the next line. Please enter your first number. And it's going to do that. And we're going to paste this down here. Please enter your second number. Okay, so this can be at the top here. So for better view, I guess we don't need this here. Might as well just get rid of that. So our int user input, we should say user number 1 is going to be this. And then copy this, put this down here. User number 2 is going to be this. Then we're going to do int total value equals user input 2 plus user input 1. Then we're going to print out the total value. So let's run this. Please enter your first number. Let's enter 3. Please enter your second number. Let's enter 4. And we should get 7. And we get 7. So there we go. We just created our first little mini program. And it just adds numbers together. So, I mean, that's a great power that, it feels so good. And the thing you always want to remember is that doing math, it's always equals on, it's always the total outcome on the left, and then this. So what this is basically saying is, the way it is we're actually storing things inside. So if we have something like this, if we have a variable here, let's call this variable total value again. We have in our code we have equals 3 plus 4, whatever it is. All what's really happening is this, the total of this, which equals 7, oh man, it's really hard to write with that. 7 is getting stored in here. That's all what's happening, is it's getting stored. So you're saying to yourself, this goes into this. So it's basically just storing it. It's not equals, we're storing it inside total value. And that's why we can say later on something like, if we wanted to, we could say total value store 11 in total value. That's all we're saying is store 11 in total value. So that's all what's really happening there kind of internally. So for the next thing you have to remember is that things go by order of operations. So for instance, if I do times 2, and we're going to get rid of this here, and we're going to comment all this out. We're just going to just do some internal numbers here for simplicity. If I say something like this, what's actually going to happen is 3 times 2 equals 6 plus 2, that equals 8, right? Right. What we can actually do is order of operations is in effect. So if I do something like this, we would expect 2 plus 3 to equal 5, and then 5 times 2 equals 10. So let's try that. Exactly. So just remember, order of operations is very, very important within programming, especially in math. So just remember that if you want to make sure something comes out correct, use parentheses where they are needed, especially when you're doing logical stuff and you're grouping stuff together in ands and ors and stuff like that. You want to use parentheses, to really, even if it's going to have the same outcome, you want it to be presentable and readable as well. So just keep that in mind. You can't divide by 0. So if I do something like this, we're going to get an error. You can't divide by 0 because that is undefined. There is no undefined within this. There is, kind of another thing where you can, do error checking and stuff like that, but we're not that far in. That's going to be for a different day. But for right now, just know that you can't divide by 0 without any extra measures. So just keep that in mind. Well, you can't do like an integer like this. So if you do something like this, obviously this isn't 1, but it is. That's what the output is, because it's as an integer. So if you were to change this as a double, it's not really that, because these are like this. So if you were to change these as doubles, then you would get the correct answer. So remember, your total, what you're going for, has to be a double, and at least one of these has to be a double. Whatever you're dividing by has to be a double. Because if we do this, we should still get 1.5. We do. It treats these, if you have 2 integers and you're dividing, it treats the outcome, even if the outcome is declared a double, it treats it as, well, I mean, technically that's a double, but the math isn't a double, So just keep that in mind. It gets kind of funky like that. If you're using division, just do doubles all around, make it easy. So, you actually get the correct, accurate answer. Next thing is going to be going to be, special operations and stuff like that. So something you may see a lot in programming, it's something like this. Let's declare int I equals 0. We'll put I here. And you may be saying to yourself, what is this? Basically, what all this means right here, what this means, this is the exact same as this. I equals I plus 4. So it would be 0 equals 0 plus 4, which would obviously be 4. Let's change this to a 2. So this would be 2 equals 2 plus 4. So basically the shortcut for just saying something like this is, I always say self plus 4, self plus 4. That's how I always remember things along this line. You can also do this like this, where it's going to be self minus 4, self minus 4. And then you can do something like this as well. This is very less common, and then this is super less common, which would be divide. I mean, I never see this thing. I'm sure it's out there somewhere, but it's just not used a lot. I would say multiplication is pretty rare, but you do see plus and minus here and there quite a bit. The other really common one is I plus plus, which essentially means, well, I'll just show you. If we were to run this, it would equal 3. It's just incrementing. So that's basically what you would say is, all this means is I equals I plus 1. And you also have one for decrementing, which would be I minus minus. So these 4 are really, really, really common. Just keep that in mind. Self plus 4, self minus 4, incrementing, and decrementing. So that's how I kind of remember those. Self plus 4, self minus 4, incrementing, decrementing. And then you do have that one that's a multiplication that is used very rarely, and I never see the division one. So let's say we have a double I equals 2.0 minus 7.0, something like that. Print I. So we have something like this, right? What if we only want part of this answer? Well, to do that, you'd have to use a decimal format. And the way you do that would be you'd use decimal format, new decimal format. Okay, you would do something like that, and then you would actually have to import this. So you can see it added it up here. And then you would actually do decimal format. Oops. df dot format I. And if we were to run that, boom. And without this, so we have a 0.29 there. Boom. So you can see it actually rounds it up like that, cuts it off, just does it the way you like it. So that can be really useful for like accounting and stuff, like displaying stuff on the screen neatly. That's one of the really the main things of it. You also have another thing here, which is the math thing, and this allows you to basically manipulate numbers in a lot of different ways. So for instance, you can have pi here. If we run that, it's actually going to display pi. If we do dot here, we can also see a lot of different things. Max, if you do max, it will give you whichever one is the highest amount. So if we do something like, if we uncomment this again, and we put user number 1 here, user number 2 here. If we put 8 here, we put 3 here, it returns 8. If we put 6 here, we put 9 here, returns 9. So it returns whatever the max number is between the two inputted are. So that's a good one. Then you have one called min, which is the exact opposite, which returns whichever one is the least value of them. Return 6. So that's another thing within the math functions. Another one probably be you have pal, which is to the power, which you can do that. Negate. They have a lot of different things here that are really useful. Another big one is, I would say, floor. If we were to, if we were to comment that out, I don't know why I keep doing shift. All right. If we were to comment that out and we were to say double test1 equals 54, something like that. If we were to floor this variable, it would be 54, because what floor means, it basically just chops it off and rounds it downward. It does it like that. Ceil, which stands for ceiling, and it's mostly used as ceiling in most languages. It's just called ceilness. Is the exact opposite. It rounds it upwards, so it should be 55. Yep. So that's another useful little tool you can have there. Another thing would be if commands. What if does is it basically allows you to, we call it an if else. It allows you to compare different objects to each other and come out with the outcome for it. So for instance, if I say if 3 is greater than 1, which we know it is, let's output true. Else, let's output false. So it is true. Let's just put that around the other way. Let's say if 3 is less than 1, which isn't true, it's going to be false. So this allows you to do a lot of different things, and I'll show you one of the things you can actually kind of create as your first little game would be something like this. I guess we could just, let's keep this here, and we don't need the second number. Let's call this user input. Please enter your number. We'll do that. We will say if user input is greater than, we need to add in another variable. So wait, let's just clear this right now. Just leave that empty for right now. We'll come up here. We will put, let's call it a new variable. Let's call it int random number equals 54. We'll just call that 54 for now. So let's say if user input is greater than 54, we're going to outprint you are too high. Else, and this goes into another thing called else ifs. So this is the most basic kind of if else, without just saying just if. But this is kind of the most basic, comparing between would be if else. The next thing would be an if else, or an if else if. So if we paste this down here, we can actually give it another parameter. So we could make it a triple. It would be if else. So something like this. So we could say if user input is less than 54, outprint you are too low. Else, well, if it's not higher than 54, if it's not lower than 54, it has to be equal to 54, correct? And this should actually be a random number here. So let's change these 54s here to random number. I don't know why I did 54. So if user input is greater than a random number, it's going to be you're too high. If user input is less than, it's going to be you're too low. Else, that means they're equal. So let's do, we will say you got the number correct. So if I do 77, I'm too high. It's higher than 54. If I do 33, I'm too low. If I do 54, I got the number correct. Now that's not very fun though, because there's no game involved. I mean, it's not a random number. It's 54 every time, and I don't want to change that every time. Well, there's a command in Java known as random number generation. It creates random numbers just out of the blue. The way you create one of these, I actually have a method for one of these, which is this. If you want to put this in your code, you can pause this video and do this. Just make sure when you create this that it is out of this first bracket here where main is. So it's going to be out of this, and it's going to be still within the class. But this is my random generation method. If you hover over random here, you can import random here. And the way we use this is we create a variable, or integer variable called whatever, and we're going to say random number. We're going to enter our lowest number, which is whatever. We'll enter 0 all the way to, let's say, 1,000. So this is going to create a random number between 0 and 1,000, including both 0 and 1,000. So it calls this random number method, sends in 0, puts in 1,000. And that's basically what this means here. What this means is it's going to return an integer, which is going to be, in this case, a random number. It's taking in the low number as an integer, it's taking in the high number integer, and then it's doing all the rest of this here, which we really don't have to worry about right now, but it's just creating that random number for us, basically. And the reason why I have a method for this instead of just using it like this is because the way number generators work is that they're always one off because they go by 0.99 decimal or whatever. It's just really annoying. So I'm like, screw it, I'll just create a method and just send in the numbers exactly how I want them instead of always being one off and messing with that. So you can look more into that if you want to, but that's how that works. So let's try this. Please enter your number. 4, you're too low. Okay, well, it doesn't actually show us anything. So let's actually print this to the screen. So if we do print here, we do print number. We run it. Okay, our number was 202. We enter something higher, you're too high. Yep. If we run this again, obviously you can see it changed again. We run something lower, you're too low. Well, let's run it again. Got a random number now. Please enter a number, 983. Boom, we got it correct. So we could see it works, but it's not efficient. And the way we get the efficiency is by using what's known as a loop. So we could use a loop here, and we're not going to get too deep into loops because this would be just like way too long. But let's just do a simple while loop. While we're going to put this whole thing right here all the way down to here. If we highlight all this, we can tab over so we can see kind of better that this is our while loop. While number or user input is not equal to random number, we're going to do this, but we need to declare our user input up there. So let's declare our user input something out of bounds, out of 1,000, so we're going to declare our user input as 2,000 to make sure it's out of the range of this, so it's not going to pop at first. And we need to change this, take the int away from it because it's already declared up here. Now let's try it. Please enter your number, 43. You're too low. Let's try 87. You're too low. Let's try 53. You got the number correct. And then it exits the loop here because it sees it is correct. Oh yeah, by the way, this means not. I feel like I'm saying like too much information at once. I'm forgetting to explain things. This means not. So this would be equals to. You always use the double equals for comparison. Single equals means declaring, or it means inputting into this. So this would mean put random number into user input. Obviously it doesn't make sense within a statement like this, so it has a squiggly line, but it means like that. Triple, we won't get into triple because that gets more confusing than we need to be right now, but double is comparison of equals. exclamation equals is not. So while user input is not random number to this. So now we can get rid of this here, because we don't want to show what exactly we're looking for, since this is kind of a game. We will also up here put this is a random number guessing game. Please pick. Try to guess the right number. And I made sure to put that out of the while loop, so it will only run this once. So in our number 3, you're too low, enter a number. 500, 800, 900, you're too high. 850, you're too low. 870, you're too low. 890, you're too high. 885, you're too high. 883, 881, 8, did I already do that? 877, 878, I got it. Now the other thing we can do is add in a number of tries. So maybe we only want to have number of tries. So we could add in int number of tries equals 10. And we could say also right here, while this, we want to put in double parentheses here, and we're going to put a space here. We're going to do double ampersand, that means and. So while user input is not random number, and this means and number of tries is greater than 0, which we'll put more parentheses right here just to see the grouping better. Do this. So we're only going to have up to 10 tries, and we also have to decrement that every single time. So to do that, at the very bottom here, we're going to do number of tries minus minus. So let's try this. Please enter your number. We'll do 100, 200, 300, 400, 500, 6, 7, 8, 9. We'll make it pop just to, that should be the last one, right? And that is. That is the very, very last one. And we could take it a step further and say you lose or you win. So for this, we're actually going to do system exit 0, and it's actually going to exit out of here, and it's just going to stop the program. So at the very bottom here, if we know it's this has happened, and it didn't get this correct, then obviously it lost. So we could say, sorry, but you ran out of tries. So if we do that, let's actually try to get this correct first. So we'll do 500, too low, 800, too high, 600, low, 700, low, 750, that was 740, too high, so it's got to be 720. Too low, 30. 725. Too low, 727. Too low, 728. Oh, I got it. So we got it. Everything's cool. Now it's just add in random numbers. It looks like it's coming up here. Boom. So that works good. And that's kind of our first little mini project there that actually works great. So yeah, I think that's about it. One thing you gotta do here is, well, we could just, nah, it's fine. We'll leave that for another way. Well, I hope this has helped you, and hope this is, helped you learn something. We'll get a little deeper later on, but yeah, I think this was a really good first lesson. So thanks for watching.